that kind of thing. So what we've got now, before lunch, which looks delicious by the way, we've got about sort of a half hour or so with the guys from Europack who are going to show us 3D scanning and how that works, with a few practical demonstrations, I suspect. So we'll hand over to those guys.
Good morning, ladies and gentlemen. The thing we've heard from Mike is about manufacturing, but we've got to make manufacturing fun as well as anything else. So what we'll try to show you today is how you actually capture data and where that data may take you, wherever it is in life. So rather than continue with a PowerPoint demonstration, we'll do an actual demonstration. And I think, like all good magicians on television, they always have a beautiful assistant standing there with the magic wand and so forth. And unfortunately, I haven't found one, but I'm just wondering whether I can ask Nicola, this lady from the council, maybe to give me a hand in a minute, because I haven't got a beautiful assistant to...
You can give her a round of applause.
So I have now got my beautiful assistant. All we need to do is if you sit on the chair. Now, you can see this isn't one I prepared earlier, is it? No. So what we're going to do is we are going to have a bit of fun. The whole idea of data capture is it's in any environmental situation you can think of. We from Europack get involved with every type of thing. For example, we do all the prototype cars for Aston Martin. We do all the Lotus cars. We do all the rally cars. We do the F1 teams. We do aerospace. We do wing parts. We do jewellery. All on from a commercial company. But the thing about the whole exercise today and what Lincolnshire County Council are trying to achieve is to open your mind up to 3D technology. If you think about it, you can actually probably achieve it. So we've got to do something very live with the lady that doesn't know what's going to happen to it. So all I'll ask you to do is maybe concentrate on that young man at the top left-hand side who helped you organise this. You can look at him and not smile for 2 seconds. That's it.
Just sit as still as you can.
And just look at him, no matter what happens to him. No, it is
a flashing light.
So if you just concentrate on him as Andy goes around. That's it. And that is real-time data capture. So this can be my beautiful assistant, who will now be processed. We forgot to tell you about it, didn't I? That's the probably more painful side than the actual side. But the whole idea, what's happening in reality is we're actually projecting a white frame, like a piece of white paper. And on that white paper is 500,000 points every time that little device flashes. So 500 little tiny points are going around the contour of the object we're trying to capture. Here you see we're actually just tidying up the data now, because those 500,000 points, every time we go around the object, we're distorting those little tiny points, which gives me the 3D image that we're trying to capture. There you go. And you can put this young lady in colour. And if we had the 3D printer, we could print her. And she could take her home to her husband and think, crikey, I've got 2 of them now.
It would be useful for meetings, actually.
Well, we thought she was absent, but she's just quiet.
Yeah, I'm going to go again. If that's okay. Do you want to watch the screen? Do you want to watch it yourself? There you go.
Any risk for people with epilepsy in their life?
Yes, it's the same with any flashback photography. We do have other lasers that don't have that effect, but in this particular instance, it's a low-cost handheld device, which obviously we're capturing people today, but really it goes across all industries, all types of applications, which we can show you some samples on in a moment. But we thought we'd have some fun, show you how it actually carries the technology through.
What do you mean by low cost in your world?
Well, medium cost is £140,000.
Yeah.
High cost is £500,000. The low cost is 13.
Right.
Okay. So, I mean, I have literally, I have a customer who she's married, she had children at school, decided that she wanted to get back into fashion industry and do things that she hadn't touched for 10 years. Persuaded her husband that she ought to have a bit of money from the bank. And she set herself up in her front room. She's now looking at scanning one of her colleagues, because when you capture this data, you're actually capturing real XYZ 3D data. And of course, if you want to make a dress or a perfect pair of jeans, you've got the perfect model to be able to make that. So you can standard material, make the tucks and bits and pieces. So, thank you. But yes, in reality, she persuaded her husband, and now this is, she's taken her friends, she decided whether she could get back into fashion. She also went to art school, and of course she's thinking about now doing digital sculptures, because from this outline here, we could actually change that, we could modify it. There are softwares out there which you can paint and sculpture with on your computer, and having done all that, you can then 3D print it. Or, just for example, we did a job the other day for Johnny Walker, the whiskey guy. They were sponsoring some sports device in Australia, forgotten to ship the big model of the guy. We happened to scan it in Manchester, sent the file to Australia, cut it into 4 sections, and because he was very big, we didn't print it, but it went on a milling machine. He made it out of wood, hand painted it, and was ready for the show. So again, wherever you think of 3D scanning, there's an opportunity to work with it. This is the type of thing that we do. Nicola was kind enough to step down. I had surprised her. She didn't know I was doing it. But it literally, within a matter of seconds, you can get a full D image. If we spent more time, we could do the same. If we asked her to stand and put her on a little turntable that you would get from a fashion shop, I could capture the whole body in about 2 minutes. We could model her up completely. And in fact, some of our clients are doing that now, taking this type of technology for their own little businesses. They have a dream, they have an idea, and they want to bring it to the fore. And by using this technology, it's handheld. We have a lot of professional people. That little device goes in a camera case. You can fly with it anywhere in the world. You can go down to Saudi Arabia if there's a broken piece down there of architecture that they want to capture in the desert. They don't want to disturb it. You can scan it, send it back via high-speed broadband if you want. So the whole idea of capturing 3D technology is it is instantaneous, it is accurate, it is not a picture, and maybe if we can rotate that around. It's not a picture, it is a 3D model. So it has depth, it has substance all the way along. So if I was reverse engineering a car, it would be a 3D model of the car. You could actually manufacture from it. So whereas it might look like a picture on the screen, it is a 3D model which can be used into any computer software. You can print it into 3D. You can mill with it. You can do what you want with it. So some of the examples that we've used this on is the medical profession. We can, a transplant surgeon in the teaching hospital in Edinburgh asked if we could do live body parts, like liver transplants, kidneys, etc. We said, probably, but how many people would lend me their kidneys while they had a go? He said, no, that's probably true. So go down to the butcher's, get a piece of pig's liver, and scan it and cut it for it, which we actually did. So we can actually scan body organs. He wanted to know the texture of it to see if it was diseased. He wanted for us to calculate the volume of it, because the volume, everybody's kidney is a different size, so I learned a few weeks ago. So from that we volumized it, and then what he wanted to do is capture this, get a database of it, because if he sent it to a colleague in London and he had one in Edinburgh, he would send it down there, they'd open it up, they'd guess the size of it. As soon as they opened it, open the chat, it's too big, it won't go in. He didn't get his transplant, the organ was destroyed, so everybody fell apart. So now we proved the concept that I could scan that liver. He would give me about a maximum of 4 minutes in a sterile environment. It takes us to a minute to scan it, a minute to process it. So I could scan it, process it, look at the texture, as we've seen here, the colour texture, I could see if it was diseased. I could then work out the volume. He could then work out whether it was acceptable for the transplant in London before sending it, and at the same time rescue that particular organ that could be used on somebody else who was a good recipient. So that's one end of the spectrum. We can use it for prosthetics, we can use it for car crash victims that want facial transplants. We can do it for any type of object you can think of, sports shoes, body parts. I'm working with Gillette for the gentlemen that want a really clean shave about how many different faces we are. We're working currently with the military because of the war conditions that we find ourselves in Afghanistan. They want better bulletproof vests, and so we are currently looking at scanning the actual chest of people, because the thickness of the material is absolutely crucial to the impact velocity of the arms. And although they could get the material probably quite right, but where it fits on the body wouldn't be right. So by taking a few hundred people which we can scan in a day, we can then get a better idea of the average chest fit. We can make sure that the bulletproof vest will be in a situation, and things like that we find ourselves in. So just to pop back to the big screen. So from that, as I say, you can take it into any industry. But this was another example. We talked about body parts. I've talked to you about engineering, F1 and Aston Martin. But heritage can come into play. Now this is the tomb of the Duke of Norfolk, and unless you're a historian, was actually the illegitimate son of Henry VIII. Now this is his tomb, and it's in a little tiny church in Norfolk. And we were asked to go and scan this tomb, and actually there were 3 in the series. And you can see the detail that we captured using the large projector. But what they wanted to do was, A, to capture it, to see if it was possible to be done, which we did. But the historians believe that this was not the church that it was originally in, and they felt it had been moved from a previous church, and that somebody had doctored it, or broken it, or changed it, or stolen things from it. So we went on site and we captured for the BBC so the whole thing. You can look at the detail of him and his wife, who's followed him through. But what they also thought, that could we capture it and really make a 3D model of it, virtual model on the screen. Why? Because the historians had found in the dungeon, if you like, of another church about 5 miles away, pieces that they believe came from the original tomb. Now they couldn't go along and chip off the new tomb, which is still already 1200 years old, chip it off and put the other part off to see if it fit. But what we can do, by capturing like this 3D model, and we did actually print a model, a scaled down model so that people could get a feel for it. So this thing was about 2.5 meters by a meter by another meter and a half. And we made a printed model so people could get a feel for where all the pieces fit. But part of the second phase of this exercise is now to take all these small pieces that they found, and we will scan those individual pieces, and then we will virtually cut the pieces off this finished tomb to the ones that they think it was originally, and we'll put the jigsaw together on the computer. So now we've got, if you like, historical forensics on whether this tomb was destroyed or interfered with in a move that was lost in the past of time. So the BBC is continuing this as a second phase programme. We're on to scanning all the other individual parts now, and we'll put the jigsaw together, and then the architects and the historian will come together and see whether this was really true. So just another example of what you can use it for, and just more example of the tomb itself. Now you can then extend it to the fairy world. So if you're into gremlins and that type of thing, you'll find people like artists will create something similar to this picture here. That could have been crafted by a very clever artist, and he wants to make replicas for the garden or for the children's grottos, etc. So you can actually work a situation like this, that we can scan an object pre-made and make replicas of it for different works. We can actually just take the design and print it and cast parts from it, or any other type of combination you can think of. We can now extend that to the film world, because film studios work with a lot of props which then get scanned into or made into computer software, of which you see in the film. So this is something which is already gone now, which we couldn't show you a few months ago. This is from the X-Man. This is his hand. So we scanned all the objects from the X-Man, brought them back into computer technology, and then you get the virtual films that you see everywhere today, actually started off as physical items which have been scanned and brought back into the computer industry. And it's the same, that's his leg, to tribute to. So you can see the detail to which we can actually capture this type of object. But okay, this is for the film industry. But if this really was for prosthetics, people coming back from Afghanistan needing replacement legs, etc., we can actually make very, very close copies. So although these are human body parts for film animation, we can extend this to the real world of car accidents, prosthetics, people who have to have surgery or whatever the case may be. So film industry continues. So yeah, I think he definitely had a good night out on Friday. And so again, we've looked at body parts. These can be masks, this can be changed. They'll animate that into a voiceover and so forth in making of the film. But this was a sculptured model of how the designer or the director said that's what the image should look like. This was made in clay, we captured it, then you can make it talk and fly and do whatever you want to do. Moving on, there was a young lady who came to my office. She said, I want to try and capture my daughter for her wedding, but I don't want to just have a photograph. I actually want to make a model of her for life. And we said, okay, we'll have a look at it. Will it be a dress, being very detailed in its design with lots of folds and so forth. We weren't quite sure whether it would work, but literally she brought her daughter to the office. We scanned her completely. She went out for a cup of coffee. We scanned the husband-to-be, so they weren't allowed to see each other, were they? They're very naughty. But this is the type of thing you can do. So that this lady decided she wanted to do it. If it was successful, I think she's going to try and make it a little business for herself, doing this type of thing. So not only will she have a 3D image that she could put on the web, she could actually go along to printing people, print little models of them, print full-size models of them, have them milled, you name it. Again, another application of 3D capture. It doesn't happen to be in the human world. This farmer, who had a very, very prized bull, so not go any further in case I get myself into trouble, but inside a magnificent range of little bulls and cows. But he was so proud